Assalamualaikum and a very good day. Today, I'll be presenting on current research in computer animation industry made by Pixar and Disney. There will be 3 interesting topics that will be discussed today. So the first one is deep learned super resolution for feature film production made by Pixar. Second one is neural frame interpolation for rendered content by Disney. And last one is the art-directed surface tearing simulation by Pixar. So let's take a look on the first one, shall we? So the first one is the deep learned super resolution for film production made by Pixar. So what are their goals by introducing this method? It is to reduce the render farm cost and deliver high resolution content. And what are the methods they use? The deep learning methods. So here is the result of deep learned super resolution. There are 3 different results from 3 different techniques that can be seen here, which are the low resolution TVI scale technique and the deep learn. It can be seen here that the image of Buzz Lightyear from Toy Story improves using deep learning, as the detail and sharpness of upscaled image is visible compared to the rest. The quality is consistent even on scenes with depth of field, motion blur, and volumes, as these phenomena were presented in the training set. Moving on to the second one is the neural frame interpolation for rendered content by Disney. The demand for creating rendered content continues to drastically grow, as it often is extremely computational expensive and thus costly to render high-quality computer-generated images. There is a high incentive to reduce this computational burden by using this method. So why did Disney propose this method? It is because rendering high-quality computer-generated images is often costly, many times requiring hundreds of core hours to render a single frame, and that is time-consuming. The method that they are using is actually they're refining the flow estimation method to produce the neural frame interpolation rendered content in order to achieve high-quality frame interpolation for rendered content. Here is the result of this method. The movement of Woody's eyes are smoother compared to other techniques, which shows that the neural frame interpolation rendered content has a stable interpolation performance for non-middle frame interpolation. And not only that, it produces a high-quality rendered content as well. Now let's see the final method produced by Pixar, which is the art-directed surface tearing simulation. There are 3 simulation phases that are needed to be performed in order to achieve this method. The first one is the pre-simulation phase, which is by implementing procedural geometric cutting tools that self-defines fractured topology. It operates with a special attribute map called stress map. The second phase, which is the simulation phase, consists of 3 subsolvers, which the first one is to deform the input rest geometry in order to detect high stress values. The second subsolver is the main finite element simulation to isolate the region of interest. The last solver modifies the input stress map, which predicts potential high stress areas during current simulation step and updates the stress map with newly calculated and accumulated stress values by analyzing acceleration. And the last phase is the post-simulation phase, which overall helps in cleaning up, reshaping, and filtering the simulation output. So this is the result in Pixar's Cars 3, which includes a dramatic surface tearing effects on Lightning McQueen's new bodysuit. The controlling and stylizing physically based simulation is one of the hardest topics in CGI productions, but they managed to do it by using the art-directed surface tearing simulation. So that's all from me. Thank you for listening.